we moved from O of the, which is the orthogonal group, to the special orthogonal group SO. So what was the additional property which made it special orthogonal from orthogonal?
Yeah, so this is related to what we have already encountered for finite groups. So the simplest groups to discuss the cyclic groups, Cn. But in physics, very often we have a reflection symmetry. We don't distinguish left and right. So we also have to discuss dihedral groups, which are non-abelian. The triangle was the simplest example. That's the same situation now in continuous limit. If you only look at rotations, pure rotations, then you are looking at the limit of this cyclic group. And that limit is called special orthogonal group. And it has a property in this particular case when you look at the determinant of every group element, because now you're looking at these exponentials of matrices, so you can always compute the determinant of such a thing. The determinant is +1, meaning that I do the actions, but I don't deform the object. That's what determinant being 1 means. We already met it when we're looking at unitary groups. They have determinant 1. If we allow ourselves left-right reflections, not being able to distinguish, then we add a discrete group element to this. And then it turns out that the half of determinants are -1. And the group that one studies, which is just orthogonal group, it preserves lengths, but you're allowed to take a pencil and invert it through the origin, which is physically a hard thing to do, but the law of that describes its dynamics allows it. So that's orthogonal group. So orthogonal group has one extra element, but that makes it much more complicated in its geometry because you encounter two manifolds. There is a manifold that we are drawing here, which is what happens when you go in infinitesimal steps from any point on that manifold, and that traces out the group manifold. What's one of the definitions of what you mean by continuous group, SO, and special orthogonal group, and preserve lengths and doesn't allow for inversion. Inversion preserves lengths, but it's a weird operation. Now, orthogonal group is richer, it's physically important, but it actually has a manifold and its copy obtained by inversion. So its topology is much harder to get your head around. So that's why we immediately go to special orthogonal groups. They have one simple connected group orbit for every object.
I'm going to make a bold statement and say that doing a TEDx talk is going to be the most transformative and uplifting experience of your life and your business. This is Kevin before his TEDx talk when I met him. He was 19 years old.